Hello everyone, good afternoon. Welcome to this problem solving session of Advanced Geomatics Engineering. We will wait for a couple of more minutes so others can join, and then after we'll start today's session. Mm, So we'll wait for 5 more minutes, like three. We'll start at 3:05. So I think we can start now. So in today's session, we are going to discuss about geographical information system and some questions related to that. As you know, in this class, we have started from surveying instruments, advanced surveying methods, such as we started with photogrammetry, then we saw different types of aerial surveys, and then GPS, remote sensing, LIDAR surveys, and so on and so forth. In the previous classes, we also looked upon the digital image processing, the images or data which we are collecting through different imaging system, how to process those data, and how to do multiple operations on that so that we get meaningful information out of it. Now, once you have the all the data analysis ready data, what to do after that? So to do any kind of sort of information from the data, we have to process those data, we have to give it to public so that they can use it, they can run a query on it, and based on that, they just do the decision making using the spatial data. So GIS is a geographical information system which provides different tools to work with the spatial data to store, analyze, manipulate, and process, and then ultimately to prepare a map out of it so that we can use it for application purpose. So ultimately, goal of GIS is to prepare a map at the end of the work or any other surveying method so that people can use those maps in the decision making. In day-to-day life, you are seeing multiple maps such as landslide happened, and you see the map showing the susceptibility of landslide areas, flood affected areas, or area affected by the earthquakes. Or if you see in a few days back, I have seen in the newspaper that they are showcasing the locations where the rental prices are increasing or the real estate prices are increasing or what is the variation in the real estate prices. So all this geospatial information will help you to take some decisions in a one or another way. So with that brief, let's start question answering for this session. So our first question is, which of the following best describes GIS? Option A, a system to store maps as image only. Option B, a computer-based tool for capturing, storing, analyzing, and displaying spatial data. Option C, a statistical database system for tabular data. Okay, hello, Shubham.
Hi, sir. Good evening, sir.
Good evening. So are you able to see my screen?
Yes, sir.
Yeah, so I will repeat again. So today we are going to discuss about the GIS. So hope you are went through the videos on that. So we'll start with the question answer first, and then after, if we have time, then we will discuss the different data sets or some software if possible. So let's get started. So the first question is, which of the following best describes the GIS? A system to store maps as image only, a computer-based tool for capturing, storing, analyzing, and displaying spatial data, a statistical database system for tabular data, and a GPS navigation application.
Sir, option B, a computer-based tool.
Yes, so it's a computer-based tool to capture, store, analyze, and then display the spatial data. The second question is, one of the key distinction of GIS compared to the other information system is its ability to manage only alphanumeric data, integration of spatial data with attribute data, focus
Okay,
on net.
integrated PPM attribute data.
Yes, so option B is correct here. Yes, hello Sachin, how are you?
Okay, sir. I am good.
Okay, great. So let's get continue with our questions. So our next question, question number 3 is, which operation is not typically associated with GIS? Overlay analysis, buffering, terrain modeling, Fourier transform filtering of audio signals.
Sir, Fourier transformation filtering of audio.
The next one is, which of the following is not an open source software? So for GIS, there are multiple software which are available. Some of them are free of cost or open source, and some of them are commercial. So you have to buy a license for that.
Sir, GIS.
Okay, Grass GI is an open source software which generally automatically installed with your QGIS, and it can be useful in the, like, if you are working with Python also. So here, if you go through the lectures, so there are couple of commercial software such as ArcGIS, GeoMedia, MapInfo Professional, then Global Mapper, Manifold GIS, Small World, uh, General Electric, Bentley Maps, and MapViewer and Surfer are commercial ones, whereas open source one are GrassGIS, Saga GIS, Quantum GIS, it means your QGIS, MapWindow GIS, ILWIS, Integrated Land and Water Information System, and Jump GIS or OpenJump. So those are open source or free of cost. So here the correct answer is Global Mapper, which is a commercial software. The next question is, in GIS, the term layer is equivalent to statistical regression model, a thematic map representing a particular data set, a random collection
Yes,
of
sir.
attributes.
No.
Option number B.
D, sir.
Which of the following applications would most benefit from GIS? Text
The
analysis.
real-time flood head.
So text solving algebra, they do not have any location based information, or generating climate models without spatial references. So for that we use GCMs, also known as a global circulation models, not the GIS. Next question is, which statement is correct? GIS integrates spatial analysis with attribute data to answer complex question. GIS is a mapping system. GIS cannot process DEM. GIS is unrelated into decision making.
Sir, option number A.
True.
Yes, it is correct.
Yeah. So next one is, which of the following is not a fundamental component of GIS? Hardware, software, spatial data, or computer networking protocol?
The computer networking protocol.
The next one is, which component of GIS is primarily responsible for analytical tools and data processing? Hardware, software, people, procedure.
The software.
Software, yes. The role of people as a GIS component, empathize. GIS is entirely automated without human input.
And decision maker.
Yes. So we as a user, we as an analyst, or we as a decision maker use the GIS for taking some or solving some problems, which is spatial problem. Which software is not commonly associated with GIS? ArcGIS, QGIS, EDAS imaging, or AutoCAD?
AutoCAD.
Yeah. So if you want that, you can also upload some data in AutoCAD, but not commonly, because sometimes if you are using the GIS data using total stations or some other surveys, you can directly import those results into AutoCAD if you have the particular coordinates well. And AutoCAD, you have made the drawing, so you can check whether, like, wherever you are going to construct a building, what is the topography there, whether it's need to cut the land or fill the land. So those things you can do, but it's not commonly associated as compared to the other softwares which are listed here. The next one is, in GIS, procedure refers to a
Rules,
physical.
models, and methods for managing and analyzing spatial data.
Option number B, true. The next one, what is the most essential component of GIS?
Software,
Huh?
the software.
Information.
Yes. So correct answer here is information because database, information database. Why? Because see, if you have software, also software are freely available. Okay, some softwares. But if you do not have data, then you cannot use it with software as well, whatever software, whether it's a commercial or open source. So main thing is, essential thing is having a data or database. Once you have database, you can use either open source or commercial software. Next one is which component is directly linked to metadata creation and management? Software, people, procedure, or spatial data?
Spatial data. D.
Yes. So wherever you have data, you have to give the metadata to the given data. So basically, metadata is like when this data is created, who created the data. This data is all about which kind of variable, how they have collected the data. So all those things are comes under metadata creation. Next question is vector data models represents a spatial feature as
Twice size polygons.
yes, so option number B. The next one is raster data is mostly suitable for
LULC classification.
hmm, because it is a continuous in nature, whereas others are discrete. You have to create a boundary or line or point. The next one is a major limitation of using raster data is inability to handle attribute tables, storage requirement increase with resolution, no spatial reference possible, and only used for vector analysis.
Storage requirements increasing with resolution.
Okay, so here the correct answer is inability to handle attribute table because in raster we do not have attribute table. It can just represent just one value, whether it's let, long, and some value. That some value can be elevation, temperature, rainfall, soil pH, whatever it might be. Okay, so storage requirement increase with the resolution, that is also a limitation. Okay, but the major limitation here is the inability of handle attribute data. If given a pixel is there, you cannot give any information that this is from this village, this state, this country, and this many people are living there. So those things you cannot attach. You have to generate a multiple DEMs or multiple rasters. So the correct here is inability to handle attribute data. The next one is in vector data. Topology refers to visual appearance of map, geometric relationships such as adjacency and
Connectivity.
connectivity.
Third option being verification with existence of
Hmm.
connectivity.
The next question is which of the following is not an example of continuous data best represented in raster? River network, soil pH distribution, land surface, temperature, and rainfall.
Soil pH distribution. River network.
So river network is a vector data. Okay, soil pH distribution is there. So that depends how we are doing survey. Okay, so if we are doing a point wise survey, then we can have vector data also. But here, if nothing is mentioned, then soil is a continuous variable. It will not like it's not like that it is available at one location and not available at different location. So because of that, we should discard the option B. The correct answer is river network as it is a vector data represented by line. Any doubt in this?
No, sir.
Which which raster resolution would capture finer details?
Per centimeter.
Higher the spatial resolution, higher the its ability to capture fine detail. Which statement is correct about vector and raster data? Raster is better for discrete. whereas vector for continuous. Vector is
The
better
vector
for,
for discrete features, raster for continuous.
yes, so vector data are discrete one and the raster data are continuous. The positional error in GIS refers to misclassification of attribute, inaccurate geographic location of features, redundancy
It's
in database
inaccurate
storage.
geographic location of features.
Which one?
Inaccurate geographic location of features.
Hmm. Attribute error occurs when coordinates are misaligned, the known spatial information associated with feature is wrong, DM values
Yes,
are
okay.
clipped. Which one?
So the non-spatial information associated with features is wrong.
Yes, true.
Option B.
Logical consistency error occurs if a river is digitized to flow uphill, GPS coordinates are missing decimal, projection is misspecified, and metadata is absent. So logical consistency is kind of you are you know that there is some issue, but you are still generating the data with the wrong interpretation of the feature. So here a river
Projections.
digitized to a flow uphill. So river will not flow uphill, it will go to down. So digitization from bottom to up, it will create an error. So that's why it's a logical consistency error. The next one, which of the following is common source of GIS error?
All of the above.
Yes, true. The answer is all of the above. So it can generate because of the digitization also, sensor noise also, and incorrect coordinate transformation. So first is relevant the digitization which we do using scanner. The second one is which will collect the data using satellite, and third one is the data which we collect using GPS. Error propagation in GIS term means errors are cancelled out after multiple operations. Errors accumulate through successive spatial analysis. Errors are eliminated by reprojection, and errors are ignored by topology.
Option B. Errors are errors
Yes,
accumulate.
accumulates through successive spatial analysis.
Yes, sir.
The next one is which test base detects the attribute errors. So there is the issue in the attribute table. Field validation, metadata check, topology rules, and sampling, resampling. So attribute table generally we design when we are dealing with some data. Okay, we took some data. Let's say we took road data. Now we are digitizing the road data. Now what we want to do, we want to give a name that what is the name of this highway. So actual name of the highway maybe let's say NH10, but people in the local language they are saying some other name, which is not unique in nature. It is coinciding with two or three other road names. So this will create a errors in detects attributes error. I mean, it will detect the different attribute error. So how we can do, we can go to field and check our data that whether whatever data we have collected it's right or not. So that additional check we can do after buying the data from satellite, and we can go at few locations and we can measure out the what is the issue. So those things we can figure it out, and then based on experience you can find out that it is because of field data or metadata check. The correct answer here is field validation. The next one is inaccuracy caused by resolution difference in overlying the raster layer is called. So inaccuracy here is like your rainfall data is available at 25 kilometer by 25 kilometer, but your LULC is available at 10 meter by 10 meter grid. So LULC will easily capture the different trends which are like cities are coming up or down. But whereas if you take resampling, sorry, when you take this another method, which is like using the some data sets and then creating attribute table and like that, then it will create some errors. So this error, which is like resolution difference, like because both the layers are having different layers, so it cannot go in hand. But current GIS software also do the same stuff like before. If it will automatically understand the error and it will try to fix it. So the here correct answer is the scale mismatch error. The most common data input device for vector digitization is
So digitizing tablet or on-screen digitization.
yes. The next one is which of the following indicates topology error? Polygon feature, yes.
Unclosed polygon,
Hmm?
gaps between polygons. So
It's a
unclosed
multiple choice option. Okay, it's written that following
yes, yes,
statements S is there.
yes. That's why I chose two options: gaps between polygons
Hmm?
and gaps between polygon. Option D, unclosed polygons, and we may include digitization error also.
So digitization error will not come in topology, but the polygon feature will come that if boundary of polygons are not closing or they are touching each other, so those things will come on inside the topology, and that's why the feature parameter will also come into picture. The next one is scanning a topographic map typically generates
Attribute tables.
attribute tables. Anything else?
Vector data.
So when you scan a map, okay, what happens that it generates your like not let's forget about the map. If you just scan some document, how it will give you as image, okay, not as a line drawing. So generally when you convert your take a map which is very old and then scan it, so basically it will give you the raster data which is in image format.
Okay.
GPS data input into GIS provider provides attribute data only, high positional accuracy coordinate data, raster grid values, and DEM resolution.
High positional accuracy of coordinate data.
Yes. During the heads up digitization, features are heads up means I'm keeping my head up and then tracing the mouse wherever the features are there. So that is known as a heads up digitization. Draw on paper maps, digitize on screen from scanned image or base map, converting converted automatically by GPS and converted by different drones.
So can you please repeat this hands-up digitization term?
So heads up means I'm looking up and then doing the digitization. It means I am making the feature like as a line, point, or polygon.
So digitize on screen from scanned images or base maps.
Yes. So option B is right. The next one is which method is most suitable for attribute data entry in GIS? field survey, GPS point, remote sensing imagery, and tabular data inputs.
The
Consider it like,
tabular data input.
yes, exactly. So option D is right. Next one is silver polygon occurs due to overlaying polygon, unslapped polygon, overshoot, or spike.
And snap polygon.
Yes. Yes.
The unsnapped polygon is confused in overlaying or unsnapped polygons.
Okay, it's in overlying polygon. We'll just see this thing in detail. So basically, what is silvering is, so you see when you have topology error, it may be undershoot when digitized vector line that could connect to each other don't touch. It should be touching each other, let's say same district file or watershed file, but they are not touching to each other, and their file or address are also different, so it will create an issue. The second thing is, if line ends beyond the limit it should be connected to, and then third one is connected to silver, occurs when the vertices of the two polygons do not match at their boundary. Whereas in overshoot, it will touch the boundary, but in between part will not touch each other. So that is silver polygon. So basically, like this, you can imagine. So answer is overlaying polygon here. The next one is, a spatial database differ from regular database because it stores only text
It
values.
integrates imagery with attributables.
Yes. The next question is, which database model is most widely used in?
So relational.
So that is known as a Relation Database Management System, RDBMS. Which of the following is partial query? Select all location where population is greater than 10,000. Select all village with literacy rate more than 80%, and select all cities with 50-kilometer radius of city.
Select all cities within 50 kilometers of.
Yes. So for that you need a layer of river and layer of city, and then you take a buffer of river with 50-kilometer, and then find out the houses which are corresponding to that. Which GIS function combines multiple spatial datasets into single layer? So if I am having 3, 4 layers, and if I want to combine in one layer.
Overlay,
Yes.
overlay.
Next one is, metadata in GIS database describes only attribute field, SQL queries, data about
The
source
data
and
about
all.
data.
The process of converting the raster data into vector data is known as
Digital
digitization.
function.
Yes, it is known as a vectorization, whereas raster, it is known as a rasterization. Which database operation is most suitable for drinking census for linking census tables with spatial polygons? So if you have some literacy rate or how many number of males, females are there as
Wow.
a district wise data, and then you have district shape file. So if you want to connect this table with your data, then which tool will help you? So it's like
So
joining a data.
join
So join will help you. So that name is table join. Then next one is DM stands for
digital elevation model.
which of the following is not a strong source of DEM? LIDAR, SRTM, GPS point surveys.
Spectrophotometrification.
Exactly. So spectral signature is not a source of DM. The next one is slope derived from DEM is measured in.
Degrees or percent right.
Hmm. The next one is flow direction in hydrological modeling using DEM is determined by maximum slope of descent from a sail, highest elevation, random assignment, or mean value of neighbors.
Maximum slope descent from a
Yes, true. So the next question is which GIS analysis use DEM for watershed boundary delineation?
hydrological analysis.
Yes. The next one is hillshade analysis from DEM simulates surface
Shaded
roughness.
relief visualization
Yes.
based on sun angle.
The next one is digital surface model differ from DEM because
It includes terrain features just like phase buildings.
true option A. Next one is which interpolation method is often used to generate DEM from irregular data point? So its name is kriging. That is a one of the kind of interpolation method which helps you to do the thing. Now I have some few questions from the previous years. So we'll go through that. So as we know that GIS is a organized collection of those things which we termed as a hardware, software, network, data, procedures, and people part. Now, the database which GIS uses, that database is known as which kind of database? So sometimes they ask you questions in a filling the blank type also, or true false also. So generally, which kind of database do we use in GIS? It's kind of connecting everyone on one page, linking different tables with each other using some unique ID. So it's relationship database management, RDBMS.
Yes,
Okay, relation database management system, RDMS. Now the next one is which one is not an open source software. So this is global mapper, which we have already gone through. Vector data topography refers to numerical data which they describes filling the blank, and filling the blank between the main features.
point
So
nine polygon.
no. Here, see, vector data, we have to talk about topology. If we are using topology, then which part it is addressing? So basically, the things which we have discussed that
So
it's
connectivity, containment, and adjacency.
yes, exactly. So adjacent, complete connectedness. So these things will come into picture here. So adjacency, containment, which is also known as coincidence, and connectivity.
And
The next one is which of the following or followings indicate or topological error. polygon feature, gaze between polygon,
That species
digitization,
data
or
upload
unclosed.
polygons.
Which one?
The digitization error.
Yes. It is like not an answer, except whatever there are, they are errors. Digitization error is not a topology error. Okay, so this kind of issue will come that line is not able to join, or here two polygons are there, but at this location in the center, the central point, or the when they took job during that time, their thing was happened so in that case also we will have this error that we are generating something and then we missed some points, or we overlaid somewhere, or overlapping happened. So those things will come under as a different names, that overshooting, undershooting, like that. Now silver polygons occurs due to overlaying polygons that we have already discussed. The process of converting the raster data into vector data is known as the digitization that we already done. Next one is which is or are type of database.
The hierarchical network and relational.
All of them are database. Okay. So,
System.
so you can see this is the example given in the notes, that this data can be at a flat file. Then like if someone is giving in that way data, then also it's fine. They should have it makes some kind of Excel file or whatever file they're making. They should have some detail on that which coordinates they are representing. Then we can convert it to our applicable coordinate system. The next one is hierarchical data. Also, you can see flat file. Also, you can see, or notebook. You can see an anaconda. Like generally, we use anaconda prompt, or which we like use for Python. So using Python, we can generate this hierarchical framework using some machine learning methods such as decision trees. Or in general, also you can visualize this link, how each and every field is connected with each other. So in relation, depending on the different relationship. So there are one to many, many to many, many to one, or one to one. That kind of relations are there in the database, depending on their unique IDs and the characteristics which they have in common. Then the next question is the correct statement is or are vector features have attribute which describes the property of feature. There is one record per feature in the vector layer. Column in the table are called records. The attributes are stored in tables. So
The
the
following above.
last statement is true, that attribute are stored in the table, and except that other two are correct, whereas the third one is incorrect because columns in the table are called as a records. So they are known as columns are known as a features, or you can say the attributes, whereas each row will represent the records. Suppose as a person, if I am having the name, surname, birthplace, so those will become my columns, and then it will be as a like the header and then subsequent values. So and one row will represent the all the information about me only. Another row about the information about the another person. So like that. So raster data is preferred in GIS for so routing the flow.
So,
Buffer analysis, we need vector data. Short distance, we need vector data. And network complex also, we need network data. What are the derivatives of DEM?
the determining volume of reservoirs,
Hmm.
amount of material removed, and determining parameters of for hydrological models.
Yes. So and
Okay.
then digging and miming operations also we can carry out using this. Okay. So I mean, there is no more questions on GIS. It's pretty easy. Uh, so I mean, what's your experience with GIS or any doubt from your side, guys? Any doubts or anything you want to ask about GIS? Have you
No.
used any GIS software before? Any one of you?
Yes, sir.
So which GIS software you used? ArcGIS, QGIS, or anything else?
Yes, ArcGIS, and actually, I also used to do easily moves. So in moves, I also tried, like, I have experience of ArcGIS online and ArcGIS Pro.
Okay. Uh, and Sachin, you have worked with the GIS before?
No, sir.
Okay, so I think both of you do not have any knowledge about QGIS, isn't it right?
Yes.
So
Yes.
sometimes we use QGIS, just like if there is an error in ArcGIS, so
Okay.
hardly we use QGIS, otherwise.
Okay, okay. So I think what we can do is I can teach you the QGIS basics, at least importing the data and doing some operations into that, because even in the next class also I mean, it's questions are similar basis only. Mostly it's application based and there is no questions, like all the questions are theoretical questions. So rather than doing those questions, I think in the next class we can do the hands-on session, or I can show you and you can just understand, and then you can try it by yourself, or you can do along with me, whatever you guys prefer. So what do you suggest, or should we do something else?
We can
Uh,
practice, sir.
Okay, so both of you, I mean, so I will uh, update this thing in NPTEL, or whenever I will upload this video on YouTube, I will put the like uh, links to download the data sets on QGIS, which we will do in next class. So if you want to do along with me, then you can do that. Otherwise, you can pay attention. We will discuss like what kind of different things are there. So there will be three applications. Suppose let's say flood happened. So how we can use GIS for giving the different kinds of compensations to people, or if we given a chance that if we want to find out the hotels like in a Delhi, which is near to the tourism spots, or which can we can use it for tourism purpose. So we can do that. So I think we'll took some kind of applications and then try to solve those applications in the next. So that sounds good to you guys?
Okay.
yes,
Yes,
sir.
sir.
Okay, so I think I will share the data with you, uh, and then we will discuss that thing in the next class. For today's class, what we can do is I can show you the different data sets, because while working with GIS, remote sensing, or survey, the main thing is you don't know from where to download the data or how my data will look like. Or basically, we are blank about the data sets. And that is the first step when we are starting any GIS related work or remote sensing. So today we will discuss a couple of sites which we can go through. Some sites allows the automatic downloads of data, whereas in some sites permissions are not given. You have to create an account. So we will discuss those data today. So I think I have listed 8 to 10 websites, and we will go one by one and just check it out. So we'll start with this first website, which is relevant to energy sector in India. So here in this website, you can. So are you able to see the website, guys?
Yes, sir.
So this is from Vedas, and this is like energy map of India. Now, in this website, if you are interested in to know that where is a different power plants are there, whether it's a coal power plant or it's a like distribution. So first thing I want to see what is a where is the coal power plants are located. So around 209 coal power plants are there across the India, and you can see in which states it's more. So if you see over Jharkhand, Chhattisgarh, and Odisha, there are multiple coal plants are there in MP, this Chhattisgarh border also. So you can see because of the land use there and the other characteristics, they are like various coal mines are there, and you can see those things. And then once you click on that, then you can get the name of that plant, district, state, and its installation capacity, that how much energy it can produce. Now, tell me first that this is which kind of data, vector data or raster data?
The vector data.
Yes. So it's a vector data and it is a point data. And then when we are highlighting on this thing, then we can see these are the attributes. So attributes are plant name, district, state, and installation capacity. So there are four different attributes. And we can see different attributes now. So at one location only three plants are there. So they have named it as a 1, 2, and STPP. And then its installation capacity is also given, district and state. So this is just one thing. Okay. Now let's say this is just for coal. Then we have diesel. So where are the diesel power plants are located? So they are located in the southern India and the northeast India part. Then we see hydroelectric power plant. So according to you, where will you find hydroelectric power plant in India? Like mostly.
in the Himalayan regions.
Yes. So because of the more amount of static energy that we can convert into electric energy or kinematic energy. So you will find most of the hydroelectric power plants because the energy is very high, which we can convert easily into hydroelectric energy. So mostly you will see these things in the Himalayan part, different uh, hydroelectric power plants. So you can see Gurubada, Sirampur, Himachal Pradesh, and then installation capacity is 60 megawatt. Uh, can you please turn off your mic? Thank you. So this is the way we can explore the data, and these are just very, very useful because if any international conflicts are happening, which is involving water, then this storage units or dams or power plant will come play a bigger role there, that they can store the water, release it, so all the operations it can handle, and it becomes a very important decision making tools. And also you can see most of like few hydroelectric power plants are also there in the Western Ghats, and here also some of them are in Narmada was also there, one or two. Okay, so similar to that, in this river also, Godavari, Mahi, you can see different power plants depending on the geography and how much energy it can produce. And then these are the small hydroelectric power plants. Then we have natural gas. So natural gas, you can see like mostly it is happening in the Gujarat and then Kolkata and Delhi, and mostly clusters are situated in some clusters are around this particular region in the Andhra, around Visakhapatnam and Vijayawada. Then there is a pump storage hydro power. So using the pumping of water, they are doing the electricity production. Then the current renewable energy things. So solar units, which are based till 2018 and then 2023, and this data is available for Andhra Pradesh only. Then if you just see Gujarat, then you can see the solar plants in Gujarat also, that which locations solar plants are there. And then you can have multiple layers, that how much solar insolations are occurring across those regions, and if at all climate change are happening, then how it will affect these solar power plants. So those things analysis you can do. Now, district wise renewable energy installation capacity. So in every district, you can go and just check on the data, and then you will get to know that solar power plant installed capacity is this much. Then solar power plants number is this much. Wind installation capacity is this much, and numbers are this much. So you can get an idea about overall distribution, that how much distribution in a given district is coming from solar, or how much is coming from the biomass, or how much is coming from wind and, let's say, different sources. Then we have waste energy is also there. So if you are interested in that, you can check that out also. Okay, so after this, now there is a district wise renewable energy number of power plants. So how many power plants are there in a different district? So that data is there. Then coal reserves are there. So different coal reserves, mines, where those mines are located, their blocks. So everything is listed in this one. And then we have petroleum and natural gas. Where is the source of that? From where we can find out the petroleum, natural gas, ethanol, or natural gas pipelines, or similarly. Then we have transmission and distribution layers. So how our transmission lines are connected with each other, so that whatever the energy which we are generating, how we can transfer it from one location to another locations, where are we having substations. So those layers. And then if some cyclone will come or floods will come, which area it will affect the probably, and how much cost it will incur to resilience back, or to move back, like to revert back to that particular situation. Then you have this renewable sources also. So currently it is showing average number of average annual solar insolation, how much solar is happening at given location. So this is a which data, vector or raster?
raster.
Yes, so this is a raster data, and this here you can see this is a solar map, and then this is a that was a wind map, and this one is solar map. So you can see in this above region there is not much solar, but in this southern part and central part are highly, like it can produce a lot of solar, and that's why we can rely upon the solar energy. Now there is a estimation of coal, lignite, natural gas, and other things. Apart from that, there is an infrastructure layer. So you have airports, where these airports are there. Then you have railway stations wherever it is. Then you have railway tracks also. Then road network data is also given. So everything is given over here. So then after the administrative units are there. So continent, country, administrative boundaries. So all of these are vector data. And some of them, like when we say base map, or the map which is kept at the bottom, that will be a raster data. Now there is a
Is
river.
it really automatically?
Yes, uh,
Okay,
y-
sir.
yes, yes, Shubham. What are you asking?
Sir, I was asking, is it freely downloadable?
No. So I can show you, like you can download the airport, railway station, railway track data, road network data. One site I will show today. So from that you can download few things, but this energy part is not available. I think if you can request or file a RTI, then they might give you this data. I don't know. I mean, But yeah, a few data I will show you how to download also today, which is in our limit and we can download by ourselves. So then we have different data like river network data is also there, wetland is there, elevation is there. Uh, and then there is a land use, land coverage data is there, and then other data sets such as so so this is the elevation and rivers and all data. We have to zoom it. Okay. And then there is also LULC data set is also there. Okay. So this is taken from Bhuvan only. I will show that portal also today. Okay. So this is just one portal which is related to the energy map of the India. So if you are in need of really need of this data, you can just print a map and then take to do the georeferencing. Like if your study area is less, okay. So let's say if you are focusing on Gujarat biomass power plants, let's say all the power plants which are in Gujarat. We'll just keep the base map also on. Let's say you want to know the biogas plants in Gujarat. So what you can do, you can just focus on Gujarat. Okay, now you can mark the different points by hovering it out, and you can see the on this right hand side top, you can see the lat long. So whenever you will go and just click, you know the latitude and longitude of that locations. So note it down. After that, go to your QGIS or ArcGIS and georeference this layer. And then after you can digitize these values. That if it is small, then you can do. If it is multiple, then it will be difficult for you. It can be doable, but it will take time. Okay, so like that you can extract the data and you can do some web scraping if you know how to do it. So then I think if it is they are allowing, then you can check it out whether it's extractable or not the data. So if this is the case, if you want to do georeferencing, then in that case you can go and click on print map and it will generate a map out of it which is showing this Gujarat part. And then once you do that, just georeference that map and then you will good to go with the small data in the small area. Okay, so I think now we will go to one more site. We'll take one from last. So this is land use statistics. Okay, okay, they removed it. Fine. Okay, so do you know about land use? What is land use? Any idea?
Yes, sir. Basically, like uh, which feature is covering that particular area, region of that land. Like if there is commercial, like there is industry, there is educational buildings, there
Hmm.
is parks.
Hmm. So in general, when we do for country or state, we'll not go into industrial or park like that. But how we classify it? We classify it as agriculture land, barren land. So basically, whatever the pixels we have, this first of all, this is a raster data, okay? And then wherever this pixel is there, we define that pixel that this particular location is majorly dominated by water. This is dominated by forest. This is dominated by barren land. So we assign a class to a given pixel that this land represents this class. And why this is necessary? Because this helps in a various modeling as well as it will help us like to find out the encroachment is happening or not, urbanization is happening or not. So similarly, there are a couple of reports or sites which already this directors of economics and statistics they give information about agriculture statistic or agriculture zonations. So here you do not have maps, but you have a CSVs or PDFs. which you can convert into the GIS format. So I can click on any of the year. Current year data are not available. So till I think 2023 or 2024, it's available. Then I think I will click on Gujarat. And then after you can go screen view, or you can just click on Excel or PDF. So let's say go with the PDF. Okay, this data is not available for Gujarat. Let's see some other state, Haryana. Okay, yeah. So what does this file shows to you? So in GIS, this today's during class we learned about the join operation. So what you can do is you can just take a district shape file of Haryana, and then after, the name of district should be same in your shape file and in this Excel file. And then after, combine those two data sets into one database, which is spatial in nature, which we referred as attribute table. And then after, you can use this data and plot this data, that which district in Haryana is having a high forest area, or which, like, so this is mostly related to the land use classification, but for agriculture and forest areas. So in this particular PDFs, you get the forest data, how much area, like now, which is the area which is not available for cultivation. So if it is not available for cultivation, then area under non-agriculture use, barren land, or barren and uncultivable land. So how much total area is not available for cultivation. Then there is a other uncultivated land excluding the fallow land, so which is a extra land. So they are like grazing fields, or they are some trees small size, or it's a land under the miscellaneous tree or crop, and groves are not included in the net area zone. And then cultivable wasteland, lands are cultivable but it is wasteland, and total of it. Then fallow lands, and then you also get the detail about the net area sown. So how much overall area they have sown as a crop in that particular district, and total, what was the total crop area. Okay, so if I'm taking a crop 2 or 3 times, then this cropped area will be high, but net area, it will consider the same pixel for one time only. Okay, and then there is also column that how much area out of the total cropped area has sown more than once. Okay, so in a year, they where is the, like, how much area is there which is sown for more than once. So those informations are also there. Okay, so you can get this kind of data sets, and this is downloadable data sets. You can download it in terms of Excel also. And if you will click for all the state and get the report, then it will generate the same report for all the states and corresponding districts. Similarly, like this, Andhra Pradesh, then you have Arunachal Pradesh, then you have Assam, okay, then you have Bihar. So like that, you will get the data related to the forest and agriculture area. Now, let's see in this portal only, if you see this standard reports, then there is a classification of area, which we have just seen right now. After that, source irrigated area. Now, this is source irrigated area is like in a given year, let's say we take Haryana only. So this will show you that what is the source of irrigation. That at a given, okay, so for this data is not available. Let's see. So it's very difficult to find out the whether the data is available or not, and if it is available, at which time frame, till which to which time frame it's available. So yeah, now this reports are area irrigated. So now if I'm doing irrigation and taking my crop, then how much irrigation in a given state or district is happening through canals. In canals also, how much area is getting cultivated by government canals or private canals or tanks or wells. So these wells you will find mostly in the southern India, not in the northern parts. Then you see other sources like main three source, canal, tank, well, and then rest of the source. Then you see that how much like if in terms of net irrigation area and gross irrigation. Gross means total and net means this they've taken considered the area once only. Okay, so this details you can get and you can see like how much hectares, okay, the given districts are doing the irrigation. So basically you can convert these tables into a map, and map means how you can turn it into around area irrigated chart map. So you can generate a map such like this, where you will show that after doing like just see. So basically how, so this is the work which I have carried out in happening to check what is happening in the deserts of Thar. So we have mapped out that like different sources that why it is getting green and all. So here we have used multiple GIS data to do our work, and I can show you like how this data, like once you get the reports, you can generate the data like this. So this data I have shown that how much urbanizations has happened in a different districts of Rajasthan. So once you have this data in a PDF file or Excel files, the data you can convert into this kind of maps where you can represent spatially that where the urbanization is happening, where the irrigation is mostly happening through canals, where the irrigation is happening through the tube wells. So those things you can carry out, and so basically this data will look like this. So here I have plotted like district wise groundwater change. So like which districts or sub districts are doing the irrigation through groundwater, and then how many districts are doing irrigation with surface water, or basically it's from river or canal, and how much change has happened in the last 20 years, and similarly how many number of wells got increased in the different districts of the Rajasthan, depending on using the minor irrigation sensor. So same data is in terms of PDF. The data you have to generate in terms of graphs, plots, so that you can use it for decision making. And these are the similar thing that how much crop area is increasing over Rajasthan or Thar deserts, how much irrigation area is increasing over Rajasthan, how much irrigation through canal or irrigation through tube wells are increasing. So you can see here the mostly the part is played from the tube wells, rather than like increase in tube well is too much tube well irrigation, whereas increase in canal irrigation is not that much. So you can get this kind of inferences from the reports once you plot it. Okay, any doubt, or do you want to know anything more about if you are working on this kind of data sets related to irrigation or land use? I will show a couple of more things. So apart from this classification of area and source irrigated area, then there is a third thing which is crop irrigated area. So crop irrigated area, if you go there and if you just check the anything, so what it will show is that how much wheat production has happened, how in how much area they have sown wheat or rice. So those things you can get to know. Okay, so you can see this is just data of Goa. So they are taking North Goa and South Goa, two districts, and then how much rice is going planted, or how much production of rice happened, jowar happened, and then basically all the cereal and millets, bajra, maize, ragi, wheat, barley, and all the including all Kharif Pak and Rabi Pak, and then you also have pulses also, then pulses, millets, and then other crops also, that says sugarcane, then vegetables or spices or any other food crops. So basically all the data you can convert into maps. And then fourth one is area under the crops. So if a given crop is there, how much area is under the rice crop or how much area is under the wheat crop. So that the information is there. So basically those kind of things you can find out from this portal. Any doubt or do you want me to explore more on this portal? Otherwise we'll move to the next part. So are you using this kind of data in your work or somewhere do you want to use? Then you can go through these websites and take a look into it. Okay, so now I think any suggestions? I mean, if
Yes,
you are working,
so that earliest website was Energy Map India,
yes,
and the second one is
I will share all the website details with you in chat or in this files which are uploading. I think I will share it on chat right now, and then after you can take a look from the whatever documents which I upload from there. Yeah, I have kept that in chat right now. Okay, so you can go through it, and I will also keep in the document file which I upload after this class. Yeah. So any suggestions? Yeah. So any suggestions with which kind of data should we explore now? Okay. So I think if we are discussing, then if there is no special request, then I think I will take one more site, which is the same about the Director of Economics and Statistics. So this is the site where also you will find the same PDFs related to the agriculture, land use zonations, and some other markets as well. So here you can go to statistics, and now here you can find the yield also, that district wise yield, like how much production capacity it has. Then this is the land use statistics map, which we were telling about. So this is the same thing. Uh, and then this is the dashboards. So they are already having their own dashboards also. And if you need some data or some other thing, you can file RTI and then just inquire about that, whether the data is available in public domain or not. Then here you also have this yield as well, and some data related to price are also there. So here you can name the state, district, crop, season, from year to which year, and then you can check the report of that particular crop. Then which district is major contributing districts. So like that also you can see, and then food crop reports also you can analyze. Then we have this information about price, sorry, this dashboards. So like how much crop and how much production has happened in the year of 2022, or important land use statistics, what is the cropping intensity. So these things, like you also can generate this kind of stuffs. Uh, if you are like want to work with these companies or GS domain, you should know how to plot this kind of way to show the information, because once you do all the GIS remote sensing surveying, you will end up with lots of data, and ultimately your task is to convert this kind of data into this kind of usable dashboards. So I think, yeah, this is about this particular site of Director of Economics and Statistics. After that, we have another site which is data.gov.in. So this is a site of sharing the open data sharing policy. So here all kind of government datas are there. Either you are working with the GIS data, or if you want to download some data for machine learning, deep learning, or whatever things you want to do. You can download a lot of data which is published by various agencies. So here, if you see, there are multiple catalogs. So here they have data depending on the different domains or different sectors. So they have particular government sites from that where they have extracted the data. So that data are also available. And then if you want to see the sectors, then this is like, do you want to download the socio-economic data or census data or agricultural marketing data or daily data, or which kind of data you need. So you have to specify that. Now let's say I want to see data on, let's say, archaeology. So archaeology related data is just this thing is available, cultural heritage in Jammu. So let's see what kind of data is there inside this. So this is a CSV file and let's download it. So to download it, you have to click on the data. Now I will just click on download, and then you have to give your applications that why do you want to download this data for whatever purpose you are downloading. And then at the end give this, and you can click on download. So now you have downloaded this data, and then you can check it out that which kind of information. So basically, you can see this. There is no data inside it. After downloading, we get to know. So this should not happen. So you have to like this is like trial and error. If data is available, you search it. So let's say we'll see what data is related to water are present here. So water quality of groundwater 2008, water level and release of water from certain reservoirs from 2014 to 15. So that data is available. So we can just check it out whether it's is there anything or not. Okay, so let's download it. Sometimes using the file size also you will get to know that whether there is something inside the data or not. So so here you can see data is there. So name of the reservoir is given. Then full reservoir level is given, depth in meter. Then full reservoir depth in feet. Then what is the capacity at full reservoir level? Capacity in like cubic feet or million cubic meter. Then highest reached meter. Then we have highest level reached till this date, like which date it reached. So lowest water reached in meter, lowest water reached date, and then total water release done. So those kind of data is there. So basically, it's having a lot of data, this particular site, a lot of data in different sectors. So you have to search. And I mean, if you are interested in shapefile or some GIS ready data, then you just write shapefile there. Uh, then you will see some shapefiles are also given, that pin code boundaries given, shapefile of rivers are already given, shapefile of airports are given, shapefile of rainfall points are given. So some shapefile directly in GIS formats are also given. You can just search about .shp. You can also state under the, so these things you can do. And then after you can search the data according to the different ministry also. So here like you can get every data sets where it's from commerce, mining, then laws, orders, defense, economy, education, environment and forest, water resource, finance, food, foreign affairs, government and administration, health and family welfare, housing, industry, So those all the data you can get from this. So how many bridges are there, roads are there? So those data are also there. Gram Sampati Gumla district of Jharkhand or something like that. So basically, mostly like lots of data are available. So you have to search crime related data are also available. So this is the some of the scenes. Health and family, water and sanitation, statistics, agriculture, education, home affair and enforcement, transportation, animal husbandry, water resource, finance. So these are the different sectors under which the different data are available. So you can go through it and this data is downloadable, so you can download it. And now we will see another one, which is India Varis. So that is mostly for water resource related data sites. So this is site is known as the India Water Resource Information System. And here couple of GIS ready data are available. For that you have to go to data downloads and geospatial data. So here, once you go, you will have multiple GIS data which you can download easily. So this data, like which kind of data are there, we'll just check it out. Administrator boundaries are there, aquifer and litholog data are there, artificial research structures are there, coastal searches are there, district water body at large, drought affected areas are there, ecology and climate zones are there, extreme events. Yes.
So actually, this website doesn't provide the accurate and like required data. Actually, when I was doing my internship, summer internship in IIT BHU, so I was doing their my project was MER, Managed Aquifer Recharge.
Hmm.
So I acquired some data for aquifers and mythology. So
Hmm. Yes, you
so
can
when I
use
tried
this.
to get the data from this website,
Hmm.
so it was not available like easily, and when I get some data, so it was also not usable,
Okay, so I think
and
aquifer,
especially
like we'll just check it out right away. Aquifer and
before
litholog.
aquifer and before. Yes, sir. So here this data is available for some common states like Haryana, Punjab, and some for only for 6 states the data is available.
Okay, okay. So
Otherwise,
that I got your point. So that you are telling about groundwater levels and qualities and all those things are available. So that is for few states. So that is available from Atal Jal site is there. So from there this is available. And here in this site, I mean aquifer data is fully available. Litholog is available. Aquifer material, major aquifer. These things are available. I can show you something. Let's say aquifer material. I will just download the shapefile of it. Let's say I'm a student. I will write my name and email. So I have downloaded this data. Now let's open it out. So I got it. Now I have to use any GIS software to open it. And about the uh, authenticity of the data, this is like ministry site. So, I mean, there is no issue. I mean, if you think there is a wrong data, then it's fine, but otherwise, no one will question it, like because this is published by government. So,
no,
you
sir,
are
it
on
is not
safer side.
wrong. Sorry, but it is. I'm not saying it is wrong, but
No,
like I was
sometimes,
saying,
sometimes
it
it
was
is
not
wrong also.
enough.
If you for that, I mean, you should know the area. Like sometimes I also know that these data which are being published, they have collected it sometimes. So sometimes I also find that data are sometimes misleading. Even if you see the Survey of India administrator boundary files, they are also having some issues that in their names, the naming systems are very different for district. Like they are having multiple special characters into it. which because of which we cannot compile it as the data and we have to do pre-processing before doing any task. So what was the case in your time? You were not able to download it, or what was the case?
So, firstly, like I was working on five districts of Uttar Pradesh, like
Hmm.
Varanasi, Jaunpur, Prayagraj, Pratapgarh, Adi. So it was not available for Uttar Pradesh.
Okay.
Especially, yes, it was available for Haryana, Punjab, West Bengal, Andhra Pradesh. For 6 states it was available, but was not
Hmm.
available for Uttar Pradesh. And some data which was available for Uttar Pradesh also. So I get it, but it was not like useful.
Hmm.
We can say yes,
Yes. So I mean that's like we have to download and we have to check whether it's
because if we say like drainage, sorry,
yes,
aquifer depth or groundwater wells, if we
yes,
say. So there was only locations like how many wells are there in particular region or in particular state, but where and exact location of these
yes. They
wells
are
were not
missing. I mean
available.
GIS layers are missing. I can understand that thing.
Yes, sir. Yes, sir.
Okay.
Like
So
only attribute data was available, like this tehsil, this district has uh, four wells, five wells, and 10 wells. But where they are existing, it was not available.
okay. So see, this is the data of aquifer and aquifer material. So Sachin, I think. Do you know what is aquifer? I think.
Yes, I know.
Okay, you are aware about the aquifer.
Yeah,
Okay.
groundwater storage.
Yes. Yeah, that's right. So we are talking about the aquifer data. So from this site, you can download the aquifer data. And first of all, we downloaded two layers. One is known as a aquifer map of India, and the another one is aquifer material. Okay. So this aquifer material is available in state only, which is Punjab, Haryana, MP, West Bengal, Kerala, and Tamil Nadu. Whereas this major aquifer is available for all over India, I mean across the India. And what kind of things are there inside it? So we can right click and check the attribute table always in vector data. So you can see aquifer is there. So visit alluvial aquifer, or it's a basement genesis complex. It's gneiss or granite or laterite, limestone, quartzite, sandstone. So which material it's aquifer? Then in detail that what kind of parameters it has, whether it's a younger alluvial or coastal, or which kind of property it has, and then it's a single or multiple system, then whether it's a confined, unconfined, or semi-confined to confined, then it's a zone that where you will find the groundwater zone, and then how much meter below groundwater level, then on an average what is the groundwater level in that particular aquifer, how will you find, where will you find the water, and then how much water you can drain out. So capacity in terms of like it's meter square per day, and then yield in terms of meter cube per day, and basically what is the yield of the groundwater which you are pumping, and the rate and everything, and then state, then taste, and then area of reservoirs, and then these things are there. Okay. So now I think we can just check it out, the change the colors and check which different kinds of attributes, sorry, we have here. So let's say aquifer classify. So we have alluvial basalt, gneiss. So you can see like here mostly it's in the Ganga plain. It's a mostly same material is there, alluvial. And then here if you see in the part of Maharashtra, some Gujarat and MP part, then the whatever the aquifers are there, they are majorly dominated by the basalt. So you can see these aquifers are dominated by the basalt rocks. And this which are in Ganga plains, they are identified like they are alluvial aquifers. And then if you see in top of Himalaya, you can see lots of variation because of the rock formations and all. So schist is there, then sandstone is there. So you can find out. Then if you go near to the coastal areas, you will find the coastal aquifers. So coastal alluviums are there. Then this is also basalt. This one is alluvial, but older alluvial. So yeah, like this. This is about the just aquifer map. And then another was like material, aquifer material. So for there you can see type of aquifer and then just name of the state. These two things are given. And here if you see the attribute table, now see here they have given this thing, that type of aquifer and then area and length. But I mean these informations are not useful to us. Why? Because here they are saying aquifer material. Okay. Now material means, what do we mean by material? In attribute table, when we are seeing, there is no information which we can relate it to, that it is representing what. So this is very poor geospatial data. I mean, we do not know anything about the attributes which we have. Here it's written the type of aquifer, but what do we mean by 100? There is no particular manual. You have to find the manual if it is there, and you have to interpret the meaning out of it. Okay, so sometimes this is a poor geospatial data because you are not having sufficient attributes which will distinguish your data. Okay, so I mean, on this particular site, you will find a lot of data. I mean, I cannot guarantee it's right or wrong, but uh, if it is right and you can search off, if you find it, if it is useful, you can use it. I mean, like gradually people are putting a lot of data in the public domain, so situation will change in the upcoming years. Hope so. So here we have floods data, forest layer, groundwater layers. We have groundwater resources estimation, hillshade, hydrological layers, inland navigations, then transfer links. So when we have this river transfer links projects, so those files, then this Jal Dharohar or minor irrigation data sets are there, land degradation data, LULC data is there, crop data is there, PMPs are there, then soil type is there, transportation data is there. So in transportation, if you see, I was telling you earlier that airport and rail line, then roads and data sets. So those data you can download it from here. And if you're working on any of the Indian parts, then you can download the administrator boundaries from here. So which is district, international boundary, state boundary, district boundary, sub-district boundary. So all the boundaries you can download from here, parliamentary or any other things. Okay. So that is all about this portal. I mean, multiple data sets are there like wildlife, water resource, forestry, transportation, telemetry, soil, aquifer, groundwater, snow. So depending on what are you interested in, you can search and download and use it. Now, just give me a minute. Then we are having this DM data set. So DM data, we can download it from this website, which I've already covered in our previous classes, which is known as Open Topography. So here you can download all the freely available DEM data sets. Some LiDAR and drone data for sample are also there. So you can download it from there only. You just have to go to download data catalog. And then you can see this is global and regional DEM. So you can download the SRTM DEM, Allos Pulsar DEM, then Copernicus DEM. So those things from here only. If you need to see how does this LiDAR data, drone data will look like in terms of point cloud or in terms of TIFF file, then you can download the available LiDAR or DM data from here as well. And then other data sets if it is available. Then you can download those also. Uh, then after we have a resource watch. So this is a data sites like when we are monitoring the various resources of Earth. This is a world website, like I mean, not for just like it's not just for India, it's for entire world. And then you just click on explore data. So here, obviously, you are having this LULC and all those things. Apart from that, you are having air quality, data related to food and agriculture, energy, climate, and society. So let's say if we see in society, which kind of data we have under the society tag. So you are having the global power plant database. So what we saw in energy map of India, some kind of data is available over here also related to coal station, power, hydropower plant and all those things. Then there is Gini index, then air quality is there, then how much plastic inputs are coming from rivers into ocean. So how much plastics are coming. So once you click on that, it will automatically show on the this side also, right hand side also, that which part people are disposing the plastic a lot. So you can think of, you can go and just check it out, given locations, and then just check it out that how much mismanaged plastic waste is going into oceans per year. So this is just one data. Then what else we have? Employment in agriculture sector, conflict and protest events around the world, environmental democracy index, air quality index, coral reefs, domestic products. And then you can also go to topics and check out the different topics also. If I click on cities, then also city expansion index, that cities expanding with how much rate. So you can see like cities in India and USA, how quickly, or even in this part of China, also you can see like how the cities are expanding. Shanghai. So basically, outward expansion index and upward expansion index. So upward is like height is increasing, and outward it means in the spatial domain. Now in India, what do you think? Which city will have more outside? Like if we compare these two index, outward and in vertical dimension. So which city is expanding vertically in India?
Mumbai, maybe.
Okay, let's check it out. So this is upward expansion index only. Okay, so let's see. So Surat, it's 0.3, 0.23. Uh, Kalyan in Mumbai, it's having 0.43, 0.43. Pune is 0.51. So Pune is expanding more than Mumbai. Like height, building of height will be high in Mumbai, but the expansion rate will be very high in Pune. It's more than Mumbai also. In Ahmedabad, it might be low, 0.13, because the buildings are expanding. The spatial index is high. It is outward expansion index is 1.67. It is high compared to the city like Surat. Like Surat also it's there. Then I think we'll just check it. Hyderabad. Hyderabad also like so many vertical buildings are coming up. So you can see the upward is 0.74. And then Bangalore, you can see it's also 0.74. And then on this side, if we see in the Asansol, so it's a 0.23, but the outward expansion is high. Then we have Bhilai, which is like okay. And in northern, if we see the New Delhi, and it's a 0.73. This one is 0.72. So yeah, you can like learn about the different thing. Like similarly, if we compare these things with the Chinese cities, like Hangzhou, so you can see like outward expansion is 11% and then upward is 5. So it's very high compared to India, like at least one in the one direction. Okay, so yeah, that is the things which you can explore. Then what else we have here? Accessibility to cities, urban population, economic capacity, cities and town, and there are like multiple data sets, so you have to check it out. Yeah, Shubham, go ahead.
So sorry to disturb you.
Mm.
Sir, may I lead the class because of an urgent work?
Yes, yes, you can.
I will cover the left
Sure, sure.
topics. Thank you, sir.
Okay, okay. So this is the website where also like along with the historical data, you will get the near real-time data also. So this, okay. So this near real-time data about earthquakes, precipitation, how much rainfall is happening. So those datas you can get. So where is the chance of earth getting hard? So significant earthquakes or earthquake over magnitude of 5 that occurred within the last 30 days. So where the earthquake happened, and you can see this like around this specific ring of fire. You can see a lot of earthquakes are happening because of this tectonic boundaries, and like mostly in the San Francisco and that San Andreas faults, you will see most like lot of earthquakes which are happening. So yeah, that's so in this side like you will get also a lot of data, and you have to search what do you want, and based on that you can work on. Next, we are having this most like portal.
सर
Yes,
अ, अभी तो दूसरा कोई नहीं है यहाँ पे।
yes,
तो फिर सर मेरा तो 2012 में पास आउट हुआ था मैं।
yes, yes, yes. बोलो आगे.
इमीडिएटली मनी अर्न कर सकता हूँ।
Yes, what are you telling?
हाँ सर,
हाँ,
आई वांट टू नो इज देयर एनी प्लेटफॉर्म आई कैन
yes,
जनरेट freelancing, generate money from freelancing or anything else, uh, if possible.
yeah. So I mean, for this particular subject, there are multiple works out there, but yeah, for that they will see your portfolio on this. So if you have good portfolio, there are multiple companies are requiring these works, and some of them, well, what skills I do see, I mean, on those works is like they are interested in not just data, but they just want to make a dashboard along with that. So some like I've seen couple of freelance works in this domain. So they are more interested in data plus some kind of dashboard. So you take some GIS data and make a
बंद कर
dashboard
कर तो
out
ना
of
बंद कर।
it. Okay.
सॉरी टू इंटरप्ट सर।
Yeah. So there are things, but yeah, for that website development part should necessary. It's necessary. I mean, I haven't gone through it much. Like I'm not doing freelancing for this thing, but whatever projects we took here in IT Gandhinagar, so they are relevant with smart cities or metros or riverfronts or so on and so forth. So you can get some work with some companies, but you connect with people through LinkedIn. And one of the students which I know, he had a lot of freelance works which has done in this particular sector. So what kind of work he used to do is like making a dashboard for a person who wants to monitor a water bodies or reservoirs, or monitoring the different irrigation requirements of a state or districts, then monitoring the air quality over schools or nearby locations where the children are there, where it's school, parks, hospitals, so malls. So those kind of works are there, which I have seen as a part of freelance works. I mean, I don't know about the exact source, but yeah, some of it are like this. So basically, you make good portfolio and publicize that thing on LinkedIn, you will get it.
ओके।
Yeah. Yeah, any other question? I think otherwise I will share one more site and then we'll close this. Okay, so there are a couple of other sites, which is like Mostek is there. So that is another site, which is from Space Application Centers, ISRO. And there you see different forecast, nowcast, then current events are also there. Then alerts are there. Then meteorological applications are there. And then other ocean applications are there. So it's a kind of temperature in ocean or which beach is clean or uh, user like you can go it without any of thinking about the water quality. Then meteorological applications like solar, uh, rainfall is there, air quality is there, soil wetness is there, and this tornado and cyclones are there. Then alerts are also there for different states. Alerts for different states are there. So you can go and just check it out what is going to happen, where it is going to be cloud bursts, cyclones, heavy rains. So this portal will give you the data about that. In addition to that, there is one more portal, which is Bhuvan. So this is kind of all the geospatial data from India, published by uh, NRSC and ISRO. And here you can see, like, if you go to this Bhuvan store, then you can see like which data is downloadable and which is not. So wherever it's written that file size download, so all these data are downloadable, so that you can download easily from this site by making an account. And then if it is not downloadable, then it will be like just NA is written there, or this data, which is the thematic service, which are not downloadable. Rest of it data are downloadable. So here also land use, zonation, urban sprawl, for floods, flood hazards, linament, geomorphology, lakes, different things are there. So you can go and check it out if you are interested. And you can also import this data directly to ArcGIS or QGIS using this WMTS layer or WMS layer. So you just put this layer as a import this data through this layer, so you can import it in GIS softwares as well. So yeah, that's it about the various websites from where you can get the data. And in the next lab, I will share some details so we can do some hands-on applications on QGIS so that you will get some more idea about the tools rather than solving a question answer. Okay, so yeah,
Yes.
that's it. Any things you want to ask?
No, sir.
Okay. So with this, we will close today's session. Thank you for joining. Have a nice day. Bye bye.
Good. Yes.